and welcome. We are going to be looking at graphing quadratics today. So in graphing quadratics, we need to know all of the little parts that we have learned before, which are solving the quadratic. That gets you when y equals 0, we figure out what x is. And that is really telling us a couple of really important points. So in the quadratic, when we're graphing, we're finding these 2 points when we solve the quadratic. So here are the 2 points that we're going to be finding. And then another thing that we want to find is what's called the vertex. So the vertex. And that is the lowest or highest point. So that's kind of what we're after today, is getting the parts that we need to graph. The only other part that would be sometimes useful, sometimes it's almost necessary to find, would be the points or point on the y-axis. So sometimes we'll want to try to find the point on the y-axis. And so that will be when x is 0. What does y equal? When x equals 0, what does y equal? So that's another thing that we're going to be looking for. And then, of course, the vertex, which we will be finding. So that's usually, the vertex is usually equal to h comma k. You don't always need to have h comma k to find it, though. There's other ways to find this point. So let's get jumping into it and see if we can graph some of these. I'm going to try to show the most simple way to graph each of the equations. So we've got our equation y equals x squared plus 3x plus 2. At this point, I would recommend using the quadratic formula. So we've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is our quadratic formula. And we're going to plug in our numbers. So b is 3, so negative 3 plus or minus the square root of 3 squared minus 4 times a, which is 1, times c, which is 2, all over 2a. Okay. Notice a is the number in front of x squared, which happens to just not be there, so it's 1. B is 3, and c is 2. So there we go. We're going to simplify. And there we got x equals negative 3 plus or minus the square root of 9 minus 8 over 2. This simplifies even further. 9 minus 8 is 1. We can simplify even further in this step. The square root of 1 is 1. The square root of 1 is 1. Because 1 times 1 is 1. And the square root is really just asking the question, what times itself equals the number inside of the square root. So there we go. We've got negative 3 plus 1, which is negative 2. Divided by 2 is negative 1. So x equals negative 1, or x minus 3, x equals negative 3 minus 1. Negative 3 minus 1 is negative 4, divided by 2 is negative 2. So x equals negative 1 or negative 2. So you definitely want to show your work while you're doing these problems. This would be side work on top of the graph. So you're going to be doing the graph as well as showing your work. So x is negative 1 or negative 2. Negative 1, negative 2. There we go. So we've got our two solutions. Now the question is, can we find the vertex? The vertex. So in this case, since we found the two solutions, we can find the vertex without having to get this into vertex form. So we can bypass the need for completing the square on this problem. So all we're going to do is we're going to find the value directly between -1 and -2. And so we can add the two numbers together, -1 plus -2 divided by 2. This is just finding what's called the mean or average. So we're adding the two numbers together and dividing by the number of numbers. This is the mean. This will get us the number right in between here. So -1 plus -2 is -3 divided by 2. And that's just a fraction that could be simplified into a decimal if you wanted to, which is a -1.5. So right in between is -1.5. But we're not actually putting the point on the line. It's going to be down here, or it may be up here. So we need to figure that out. We need to figure out how far up or how far down it is. But we've got the number, -3/2 or -1.5. Either one of those numbers is going to work. So we know that the vertex is -3/2, comma, something. We need to find that something. What is y when x is -1.5? So we're going to do a little bit of math, so we'll do it over here. Y equals, I'm just writing this equation down, but everywhere I see x, I'm going to replace with -3/2. All right. So we've got y equals -3/2 squared plus 3 times -3/2 plus 2. -3/2 squared. Well, -3 squared is 9. 2 squared is 4. So -3/2 squared becomes positive 9/4. Plus, we've got 3 times -3/2. So 3 is in the numerator and over 1. So 3 times 3 gives us 9, and it's actually negative. So we're going to have a -9/2. Okay? Plus 2. We need a common denominator. So the common denominator between 4, 2, and 1 is 4. That's the lowest common denominator. They all can be multiplied to make 4. So we can multiply each of these numbers by something to make 4. So here we've got 9/4 minus 9/2 times 2 over 2. 2 times 2 is 4. This is going to get us a common denominator of 4. Plus 2 over 1 times 4 over 4. Again, 1 times 4 is 4, so we're going to get a 4, and a 4 in the denominator. That's the common denominator. So 9/4 minus 9 times 2 is 18/4 plus 2 times 4 is 8/4. So 9 minus 18 plus 8. Okay? So 9 minus 18 is -9, plus 8 is -1. So we're getting -1/4. And that's what y equals when x is -3/2. Y equals -1/4. So there we go. This is again side work that you should be showing, and it is important to show your work. You don't have to show every step. If you can simplify by skipping some of these steps, that's totally fine. I'm just showing my work so that you can see where this is coming from. So I did show a lot more work than I probably had to, especially in this step. So this would be kind of a shortcut step. You don't really need it unless you need it because you can't see it without writing it out. Then you would show it. Okay. So we've got negative 3/2, negative 1/4. So we're actually going down to negative 1/4. So x is at negative 3/2, y is at negative 1/4. So 1/4 of the way to negative 1. If this is negative 1 here, then we're just going down 1/4 of the way. So there you go. The other point that we might want to find, so before I make the U shape, before I make that, I might want to try to find the y value. So what is y when x is 0? So that would be the y-intercept. Here are the x-intercepts. Let's go ahead and see if we can find the y-intercepts. I'm actually going to make it as a point. So this is the y-intercept. Okay? So for the y-intercept, we're going to plug 0 in for x. Okay? So this is another piece of side work. Y equals 0 squared plus 3 times 0 plus 2. I just wrote this equation down here, except for everywhere I saw x, I replaced it with 0. Okay? So 0 squared is still 0. 3 times 0 is 0 plus 2. So 0 plus 0 plus 2 is 2. So we get 2. So if we go up 2, there we go. We've got ourselves the y-intercept. This can help make the graph a little bit more accurate, because otherwise when we go to connect we might shoot it up really fast, but it actually comes over. It's actually coming over. And the other nice thing that you might note is that if you've got the right hand side of the graph, the left hand side is just the mirror of it. So this is just a mirror image. So if we go up 2, we went right 1.5, up 2 from this point. Right 1.5, up 2.25 actually. So we're going to go right 1.5, 1.5 from this point, 1.5, up 2.25 from here. So 1, 2. And that should help us to make it fairly symmetric. So there we go. And that is graphing the parabola. And we've not only graphed the parabola, but we've also identified all of the important parts. The vertex, the solutions, the y-intercept, and the just the mirror image of it. So this point's not necessary, but just makes it look a little neater. So, okay. All right, here is our next equation. We've got y equals x minus 3 quantity squared. You could write it out. That might be a good idea. So we're just trying to solve right now and find our x-intercepts. So I would recommend y equals x minus 3 times x minus 3. That's what squared means. You're just multiplying this times itself. So if a times b equals 0, and we are plugging 0 in to find the x-intercepts, we're plugging 0 in for y, then a must be 0 or b must be 0. So we can rewrite this as x minus 3 equals 0, or x minus 3 equals 0. So it looks like we're going to get the same number twice. So we're going to add 3 to both sides, add 3 to both sides, and we get x equals 3, or x equals 3. So 3 comma 0 is the only solution to this problem. So we are going to graph. Three comma 0. So this graph is going up or down. You have to figure that out. Should be going up. And we need to figure out a couple more points. If we don't get at least 2 more points, we wouldn't have a nice symmetric curve here. So the next point that I would say we want to find would be the vertex, but we know the vertex. This is the vertex. If you only get one solution, then the vertex is 3 comma 0. This is our vertex. So we've already gotten our vertex. So the next thing we want to find is the y-intercept. So sorry. There we go. Okay, so when x is 0, what does y equal? Well, we can do that pretty easily. Y, so we're doing some more side work. Y equals 0 minus 3 squared. 0 minus 3 squared. So 0 minus 3 is just negative 3, and negative 3 squared is negative 3 times negative 3. So y equals 9. 0 comma 9. Hopefully that makes sense. So we had to go left 3 and up 9 from this point, the vertex. So we'll go right 3, and up 9. And I made that a little high. Let's go a little up there now. And there you go. That's pretty much as good as we can get. Obviously, we could have plugged in 2 in for x to find some other points to see kind of how it curves. But this is the requirement. The requirement, the minimum requirement, is that you find the y-intercept, the x-intercepts, and then mirror it over. All right, this is our next equation. It is already in vertex form. This is already in vertex form. So vertex form is y equals a, x minus h, quantity squared, plus k. Okay? this A is the same A in the form ax squared plus bx plus c. However, there's no b in c because it's been changed. So h is the x value and k is the y value of the vertex. So that's why it's called vertex form, because the vertex is h comma k. So we can identify what h is. So looking at our equation, we need to make sure that this becomes a minus something. So two negatives make a positive. So we could rewrite x plus 1 as x minus a negative 1. X minus negative 1. H is negative 1. So our vertex is negative 1, comma, plus k, plus 1. So it is 1. So negative 1, comma 1. So that's our vertex. So we're going to go ahead and graph the vertex. Since we know what the vertex is, we might as well graph that. So negative 1, 1. We've got our negative 1, 1. That's the vertex. That is the either highest or lowest point. In this case, it's the lowest, and we know that because this is a positive number. If this was a negative number, then it would be the highest point, and the shape would be going down. So, since A is positive, it's pointing up. So that's how you can tell which direction you're going. So, since it's going up, we know that the x values, the values for when y is 0, are imaginary. So we don't even need to try to figure out what the points are on the x-axis, because they don't exist. So instead, let's just find what our y-intercept is. So we're going to plug 0 in for x. So y-intercept is 0, comma, something. Okay? And so we're going to plug 0 in for x and see what we get. So y equals 2 times 0 plus 1 squared plus 1. Simplify. 0 plus 1 is 1. 1 squared is 1. So I did a couple of steps there at once. 0 plus 1 is 1. Then I squared it. 1 squared is 1. Got rid of the parentheses. 2 times 1 plus 1. 2 times 1 is 2. Plus 1 is 3. So we get 3. So 0, comma, 3. So this is the vertex. This is the lowest point, and it's moving up. We went over 1, up 2. From this point to this point, we went over 1, up 2. So we want to go over 1 the opposite way. Over 1, up 2. And there's our parabola, and we are done. So that is as much as you have to do for these problems. Okay? So this is a unique problem to what we've done so far. If you notice, if we multiplied the x's together, we get negative x squared. Negative x squared. So this is a negative, so that means that our parabola will be facing downward. And we haven't done one like that yet. So our vertex will be a maximum instead of a minimum. So that's what's going to happen. Let's see if we can graph it. It's already in factored form. So since we are in factored form, we can just figure out are zeros. Negative x plus 2 equals 0, or x plus 3 equals 0. So those are our two. We're going to subtract 2 from both sides. Divide by a negative 1. That gets rid of the negative. So then we find what x is, not what negative x is. X is 2, or x is negative 3. Okay? Hopefully that's making sense. So I'm going to write that over here. I'm just going to write them as points. So we've got point 2 comma 0 and negative 3 comma 0. Again, I want to find the vertex. I do not need it in vertex form to find it, though. It's the point between these two. So what number lives directly between 2 and negative 3? Well, we just add the two numbers together, divide by 2. That finds the mean, or the average. So the average is the point right in between them. So we get negative 1 half. Negative 1 half. So the vertex is negative 1 half comma, or negative 0.5, if you like decimals better. So negative 1 half comma y. We're going to need to find the y. So we're going to plug this back in and solve. So this is probably the most painful part of this type of equation, is you have to plug this number back in, and it's a fraction. So we have to plug it back in for x. So y equals negative 1 half plus 2 times negative 1 half plus 3. Sorry, negative y, right? It's a negative 1 half. So double negative 1 half plus 2, and then a negative 1 half plus 3. So, all right. Y equals, two negatives make a positive, so it's still positive 1 half plus 4 halves. 4 divided by 2 is 2. I have a common denominator now. Negative 1 half plus 6 halves. 6 halves is 3, and we have a common denominator. So y equals 1 plus 4 is 5 halves times negative 1 plus 6 is 5 halves. This is really common. This is really common when you plug in for the vertex. These two numbers are usually going to be the same number. So it's something to keep in mind, that that's pretty normal. If that doesn't happen, you may have a problem with your work. 5 times 5 is 25. 2 times 2 is 4. 25 fourths. If you're having a hard time visualizing what 25 fourths is, think about if you had 25 fourths. A fourth of a dollar is 25 cents. So that's 0.25 of a dollar. 25 cents. So we have 25 cents. So how many dollars would you have? You can figure this out. You could just take 25 divided by 4. So if you did that, you'd ask how many times is 4 going to 25? And that would be 6 times. 6 times 4 is 24, with a remainder of 1, so 6 and 1/4. So 25 fourths is 6 and 1/4. So that can be helpful. Or 6.25. This is negative 0.5. So this is just another way of writing that number. These are the same. So we can graph it. If we need more information, we can get it. We've got our x and y axes. 2, 0. We've got -3, 0. And then we've got -1/2, 25/4, or -1/2, 6.25. So we're going over 1/2 left, and then we are going up 6.25. So there's 7, so 6.25. Somewhere in there. And the other thing we could find is the y-intercept. That could help a little bit with the picture if we have our graph well made. So we can plug 0 in for x to find the y-intercepts. Here are our x-intercepts. These two are our x-intercepts for our solutions. This is our vertex, written 2 different ways. Same number though. And our y-intercept is when x is 0. So we can plug 0 in. Zero plus 2 is 2. 0 plus 3 is 3. 2 times 3 is 6. So there's our y-intercept. So y-intercept is 0, 6. So if we went over 1/2 to get over here, we'd actually be at the same point. So we're just mirroring it. And there you go. So it's fairly smooth at the top, and then it's coming down. So, and it starts to come down sharply. As we go to the right, we're going down faster and faster. As we go to the left over here, we're going down faster and faster. But we could still plug in the number 1 million in for x and find y. 1 million over. Because it is still going that direction forever. It's just going down faster than it's going over, but it's still going over for forever. So if you plugged in 1 million in for x, you would find y is much, much greater number negatively. So it's just an astronomically huger number because it is going down much quicker than it is going over. But it's still going over. It doesn't look like it, but it is. So it's not going straight down. Okay. That is generally graphing quadratics. If you have questions, please let me know in class or Canvas message me. All right, thank you so much. Have a good day.